Welcome to our webinar on the importance of connected devices testing. We're excited to have Randy Rice with us today to talk about connected devices testing. Randy is an accomplished author, keynote speaker, educator, trainer, and all-around resource when it comes to software testing. So I'm excited to get his take and insight on connected devices testing today. Randy, welcome to the webinar and thanks for presenting today.
Thanks, Dave. It's a pleasure to be here. So I'm excited to be discussing this domain of connected devices and how to test them. We're going to look at some of the things around that and also the syllabus from at SQA on connected devices testing and what that's all about. So as kind of a roadmap for the presentation, here's some of the things we're going to be discussing. First of all, I'm going to build a little bit of context here about, what really are connected devices. It's really kind of a term that has been coined to be kind of all-encompassing of mobile and IoT and those kind of things. So I'm going to break it down a little bit more. Also, what are some of the challenges that testers face in dealing with trying to test these devices? Then I want to get more into about the certification. Why do we need this certification? What value does it have? And then give a little bit of background and view into the connected device syllabus from at SQA, and then also a little bit more about the certification details, because there are a few differences in there that I want to kind of bring out. So in looking at the idea of connected devices, over the years, we've seen this just mass proliferation of things that are connected into the internet. I've been working with mobile devices now and testing those and training on how to test those for 20 years. I know that sounds like a long time, but I looked back through some of my files and my presentations, and one of the very first ones that I did was in the year 2000, believe it or not. Back in those days, we were dealing with things like Palm Pilots and flip phones and stuff like that, feature phones, those kinds of things. And of course, from that point to where we are today, we've seen just this incredible leap in what these devices can do, what they control. And so when you look at this whole domain, just to call it mobile application testing or mobile device testing is really very limited. So we also need to understand that we're dealing now with not only the Internet of Things and the connected devices that are involved with that, but also that things that are controlled by connectivity to the web that you may not even really immediately think about. And I'm going to get into that a little bit here. Really, just about anything that is capable of being joined to the internet could be in this family of connected devices, all the way from mobile devices, which could even be as basic as a flip phone, a feature phone, which, by the way, is kind of making a bit of a resurgence to the Internet of Things. Now, I found this graphic. At first, I had developed a slide that kind of showed a decomposition of things, but I thought, wow, this graphic really does kind of tell the story of a lot of things that we can think about as being connected devices. And you look at this and you'll see some kind of funny things in here, like there's a blender here, there's a lamp, there's transportation like airlines, there's entertainment, there's cooling fans, there's even a drill in here, there's speakers. Then you'll see a desktop PC, a webcam, a tablet. You'll see actually somewhere in here, there's, oh, there it is. There's the cell phone, your refrigerator, your car. And then you'll see it's all kind of connected into the cloud with other kind of things that are going on, like you'll see like shared calendars and disk storage and timers and analytics. And it's, when you take it all in together, it's just staggering as to what's being controlled here. I forgot to mention also gaming is another big part of this as well. So the connected devices are all talking to each other. They're all communicating, and we normally just expect that these are going to work. The team that I work with right now, we call this the infamous should. Yes, it should connect. It should work seamlessly. However, real life has taught us that that doesn't always work that way. Certain sites go down at certain times. Devices sometimes fail to work with each other when a change is made. And so that can be an issue. But when we talk about connected devices, we're talking about this entire family. In fact, it's more of an ecosphere of things that just work together on the web. And whether it be making a phone call, whether it be controlling your lights in your house, or even cars that you drive, then these really can be considered in this whole topic that we're talking about here. Now, the other question that I kind of want to address is, well, why do we need to have high levels of quality in these devices? So I'm kind of looking at it from two perspectives, at least in this slide. The first is the importance of mobile app quality. And when you think about all the things that can be done with mobile apps these days, it's also amazing. I mean, it's an ongoing march of stretching the capabilities of what can be done in mobile apps in whatever business context you're in, or maybe even governmental or organizational context. And the thing to understand is that this is not a technology thing on its own. Yes, it is driven by technology, but the big importance of this comes in at the business layer, because businesses are typically judged on how well their mobile apps perform, not only from a response time perspective, but also from a functional perspective. So if your mobile app isn't very good and people have trouble with it, it doesn't take long for that to start rubbing off onto the reputation of your business. And some businesses, for example, like Uber, they are like super highly dependent on the ability of their apps to function correctly. If their app were to break, the drivers wouldn't be able to find the riders, and the directional capabilities would also be wrong. The calculation of fares could be wrong. In fact, there have been problems on that app in the past, and there's some major fallout from them. But anyway, it's just an example of how critical these apps are. Another example is airlines. For those of us who are frequent flyers, we depend on these apps quite a bit for our itineraries, for the status of flights, for changes in flight status, and all those things. And if you go out to the App Store and just start looking at the reviews on some of the various airlines' mobile apps, you'll see that some of them rate pretty low. And if you start reading the reviews themselves, it's kind of interesting because before long, they transition from talking about the app to talking about the airline. And so they may be giving a review of the app that says, well, it was hard to use. I got these crazy error messages. It didn't show my flight time correctly. And then they'll say, and by the way, XXX airline is really terrible anyway, because they charged me a ticket change fee and all that stuff. So it's kind of funny to see how they digress sometimes. But here's the thing. So there's this downside risk, but also there's this very high opportunity that you can see from having a really good mobile app. And that's where I like to kind of play into that space. I don't like to kind of just approach this from the standpoint of, if you mess up, here's what's going to happen. But what can you gain if you really have a great quality app? Oh, the question I get quite often is, well, do you actually do this stuff? Yes, I'm a practitioner. In fact, yesterday I was testing a mobile app, and I'm not just talking about as a user, I'm talking about this is what I do as a job. And one of the things now, as we're recording this, we're right in the middle of the COVID-19 pandemic, and the mobile apps are starting to play a really big role, like in grocery delivery and food delivery and those kind of things. And so I had occasion a couple of days ago to be in an area of town where I live, where I needed to get something to eat. And so I used the mobile app that I actually work with to test the order ahead functionality. Is for a fast food chain. And so I was able to test it. I made my order. In about 5 minutes, the person came out of the restaurant with my order in a bag in their hand. I took it. And so I can now say that even in a pandemic, this app works correctly. So it was kind of interesting to see in a real world validation that it worked. Something that's also kind of interesting here is that if your app performs so poorly that it gets consistent 1-star ratings, then they'll remove it from the App Store and the Play Store. Apple and Google will do that. It's kind of a funny story in that regard too, in relation to the pandemic. I believe it was in China, they went to a lot of distance learning for the school kids, and a lot of it was through mobile apps. And these kids got very creative about it, and they downrated the app on the App Store's website and the Play Store, and it actually got removed. Now, I don't know how the story actually ended, but I thought that was kind of an interesting hacking of that whole that reality that low scoring apps can be removed. And then also consider that some of these apps are very, very critical to the people that use them. Now, I know that, yeah, I want to get to Facebook and I want to do the things that I do kind of entertainment wise. I have my favorite games, but I'm talking safety critical stuff, mission critical things like, some of these apps are used to send medical readings to a physician. Also, first responders use a lot of mobile apps to do what they do. And if the apps aren't working, then lives can be at stake in that case as well. It could be other things like GPS, if you're depending upon an app to tell you where to go, and it tells you to turn just after you need to turn, or it gives you incorrect routing just generally, then that could be a problem too. Now, as we look at the Internet of Things, these devices also have high criticality because when they fail, the impact can be quite large. A lot of people think of the Internet of Things in terms of things like home automation and, turn my lights on, Alexa, what time is it, that kind of thing. And that's important because if you walk in the door and you say, Alexa, turn my lights on, and nothing happens, oh my goodness, you've got to use a light switch. But still, that could be maybe an issue at times. But consider that one of the biggest areas of Internet of Things that a lot of people don't really think about or talk about is that of industrial Internet of Things, where factories are being controlled by the Internet of Things, and all kinds of sensors and devices all having to work together. And when failures occur there, then you have a plant shut down, or you have someone get injured because of a failure in that device. So a lot of criticality in the industrial side of IoT, as well as the automotive side of IoT. Now, when you think about automotive stuff, you don't typically think of cars being as a system of systems, but they truly are. I found this graphic, which is really interesting, just to show all the things that are considered subsystems in a modern automobile. And you'll see that they range all the way from like the entertainment system here to things like navigation systems, security systems, exhaust noise suppression. Some of this even has to do with engine operation, like electronic throttle control. There have been issues with that before, that people have been killed because either the car died in the middle of the road or it sped up and they couldn't stop it. Electronic valve timing, cylinder deactivation, so that you may have a 6-cylinder car, but if you want better mileage, then it knows how to disable 2 of those cylinders. It's just amazing what can be done. And some of these things are controlled by the Internet of Things, especially like with communications. There's one of the voice and data communications is one of the systems here. Electronic toll collection is another one. And as the average user or driver of the car, you don't think about all of these things going on, but they are. They're all having to work together, and it can be quite mind-boggling when you think about it, all the things that have to work together, and then having to test all of these things. It's a really big challenge. So the challenges for testers are that these devices are everywhere, as are the users, and nearly everyone is a user. And never before have we really seen in software such a varied and large user community. Like almost everyone is using some form of smartphone, if not a smartphone, at least a feature phone. Nearly everyone is connected in some way, once again, whether they know it or not, to the things that they're using. And the thing about it is that the way that companies are dealing with releasing connected device software is that it's not so much on a delivery time schedule anymore. In some cases it is, but also in more and more cases, the idea of continuous delivery has become the norm, the whole DevOps kind of thing. And that means rapid testing, that means automated testing. And another thing that's kind of a fallout from this is that it's more and more common to see devices fail because you push out a change and then you learn that, oh, that change isn't compatible with my Home Assistant device, or that's not compatible with something else that's going on in a connected device. So just because one device gets updated with new software doesn't mean that all the devices it works with are going to necessarily work and play well with it. However, that's where the rub comes in, because there is this expectation that applications will just work across all the devices and that all the devices will work together and that everything will play well together. And well, you've probably experienced that in your own usage of mobile devices and connected devices, that is not always the case. In fact, it's common that you'll get an update of an app and then about a few hours later, another one will be pushed out because of a problem that's been discovered. So in an effort to address some of these challenges and to give testers some resources to at least understand maybe a framework and how to think about testing, the tools that can be used, and those kind of things, that was one of the driving factors behind this certification. The desire to have this wide-ranging practical certification that's up to date with current technologies was a big driver here. The idea that it would just be a mobile certification is okay, but also to expand it out to the whole realm of connected devices made it much more inclusive. One of the things also that was realized was that there's this whole body of skills and knowledge that need to be in place as organizations continue to create mobile devices, or at least have them created and test them and deploy them. That whole challenge is ever growing because the features are expanding and the audience is expanding. And so it's an ever growing need in organizations to be able to develop and test these applications. So the domain just does not stay still. It's continually marching on. And for a tester, to be able to have these skills is a very valuable and marketable thing. To be able to say, yes, I know how to test mobile devices, I know how to automate the testing, I know what the risks are, I know how to do planning. Those are big things. And so one other thing, though, too, is to have a framework for continuous learning, because if the march truly is constant, which it is, then that means that you have to be learning new things all the time. And so this certification is ISO compliant, which means that not only does it comply to all the things that should be in a certification, but there's also the continuous learning part of that standard that is important, because to really say that, yes, I'm certified at the ISO compliance level, then there is that recertification aspect to this certification. Now, about the syllabus, there are several major purposes that are staked out, and these are actually found in the syllabus itself. For training providers, the purpose of it is to produce courseware and to determine appropriate teaching methods so that students can be able to learn based on the learning objectives. In this syllabus, the learning objectives are much like are in other certifications for software testing. You have ranging from K1, which are things that you should be able to remember and recite back, like terms and those kind of things, to K2s, which are the things that you should be able to understand the rationale for, to K3s, which are the things that you should be able to practically do. And this syllabus and this certification requires that you're able to actually do the things that you're learning in the certification that's driven by the syllabus. Now, as a student or a certification candidate, the syllabus is there to help you prepare for the exam, either part of a training course or to independently self-study for the exam. And for the entire community of software and systems engineering, it's there to advance the profession of software and systems testing, as well as to be a basis for books and articles and courses and all the other things that would be a result out of this understanding of this domain. So in the syllabus, there are 6 major chapters or topics in here that work out to approximately 2 days of training if you include in the exercises. So just like in other syllabi, we have recommended times that you will see here for minimal time that needs to be covered or devoted to a particular topic. And the reason I put the times in here is because it kind of helps to show the areas of emphasis and the scope of where the material is. So the first major topic is just kind of an introduction to what it means to be testing connected devices. And then there's a treatment of test planning and design and how that fits in. You'll see a major area of focus here will be on testing the quality characteristics for connected devices, which would include things like usability, security, performance, those kind of things. The attributes you might think of, but also it deals with functionality as well. And then the environment and tools. We know that tools play a very important part in testing connected devices, as do having the right environments that will replicate the real world as closely as possible. That's another major area of focus. Then we give special treatment to the Internet of Things, what's the impact? How do you approach it? How do you create a strategy for testing those? What are the things you need to pay attention to? What are some techniques you can use? And then the idea of future proofing, which is how do you create tests that are somewhat resilient to change, and also how do you anticipate some of the changes that might be coming about in the whole world of connected devices. Now, at this point, I would like to kind of take a view of the syllabus. And one of the first things you'll notice here is that it's got this, I think, a really sleek design to it. You'll see in the table of contents all the things that I just mentioned, all the major areas, but you'll also see the drill down of things, like on the quality characteristics. I mentioned functional testing, but there's also security, interoperability, those kind of things, performance testing, usability testing, portability, reliability testing. And then on the tools, there are those that are generic as well as commercial or open source kinds of tools, environments and protocols. You'll see also some special application-based considerations. So you'll see that some of these are particularly applicable to mobile devices, where others can be applied to either mobile devices or Internet of Things, all the family of connected devices. Speaking of the Internet of Things, here's the section on that. The nature, the challenges, the risk, the benefits, how they're implemented, like appliances, wearables, automotive, industrial, and then the unique testing approaches and techniques needed for the Internet of Things and the role of tools. And then on the future proofing, about rapid growth, building for change, and making the apps and the things that we use in the connected device world resilient to change, and being able to adapt with that, as well as being able to plan for the future. So just scanning down a little bit further here, you'll see that syllabus will contain all the learning objectives here, for each of the major topic areas, like what is a connected device. There's a K2 to understand the challenges behind that, challenges for testers, necessary skills, and so forth. So I'm certainly not going to read through the entire syllabus here, but just to kind of give you an idea and a teaser as to what it looks like here, the skills, equipment requirements, life cycle models. There's a lot of things covered in this syllabus that hopefully will be of use to you, not only in preparing for a certification, but just in being able to test the context of connected devices in general. So anyway, that's kind of just a real quick run through of what that syllabus looks like. Now, to get the syllabus, you can go to the ATSQA website at atsqa.org/educational-resources. That's where it can be found. And the exam is also offered through ATSQA, and you can find details on that at the same website. The exam is 1 hour in length, has 40 multiple choice questions, but I need to emphasize one more time here that some of those questions require that you're actually able to do the things that we talk about in the syllabus. And so it's not all theoretical knowledge. It's, you know, there's a lot of practicality to this, that you're going to have to be able to design test cases. You're going to have to be able to do things like selection of tools and those kind of things as well. Now, I did mention about the ISO standard aspect of this, which requires that there is a recertification. That's going to be a 3-year period, and it's going to be based on continuous learning and other professional development activities. As for training, there'll be various training options that will emerge as the syllabus becomes more popular and gets launched out there, and all the training providers, including myself, will probably be creating courses after we, kind of see what it takes to do that. And but there will be training options that will be available for you. And if you're interested in knowing who's providing training, then there'll be a list of the training providers out on the @sqa.org website. Well, the next steps, if you're wondering, where do I go from here? I would recommend, first of all, going to the link that I mentioned at sqa.org and download and read the syllabus. And then from that, you'll be able to further judge about the need for training and to get some deeper understanding when it's available. The thing that I always tell people about all the syllabi that are available is that the purpose of the syllabus is to describe the what you need to learn. Okay, it's the what, it's not the how. The purpose of the syllabus is not to teach exactly how to do all the things that the syllabus covers. That's where the training comes into play. And so there will be times in any of the syllabi that are out there for certification that it says, here's what you need to know. And it will give some bullet points and a little bit of detail around that. But then when you actually get on the exam and you see a question related to that syllabus topic, it's going to require that you have some experience in actually understanding some of the deeper things around those items. So the syllabus is just the starting point. The training helps you go deeper and will help you be not only better prepared to take the exam, but you'll walk away from the training with the skills that you need to actually apply that information that's in the syllabus. So once again, I encourage you to consider training, and also you can register for the exams at the @SQA website. So at this point, I am completed with the information that we have in the webinar here. I'd like to thank you very much for attending today's session. I have my bio slide if you're interested in any of the things in my background. And also, if you have any questions arising out of the webinar, then feel free to contact me either through my website at riceconsulting.com, or you can email me directly at rrice@riceconsulting.com. But I hope this has been a helpful and informative webinar for you. And once again, if you have any questions, feel free to contact me. And I hope that you find this, I hope that you actually take action and go and look at the syllabus, and that it would be of help to you in your career and for your company. So at this point, I'm going to turn it back over to Dave.
Randy, thank you very much. This was great. It's a great introduction to what's included in connected devices testing. Some great resources. Certainly, the syllabus by itself is really a shining example of laying the groundwork for developing that knowledge, for training, and for just the basis of knowledge itself. And I think this is pretty exciting stuff. I expect that this will continue to evolve over time, and the continuous learning aspect of this could never be needed more, I think, with a topic such as this, because this is something that will be evolving constantly. So it's an exciting one. As you noted, if you can develop the skills of connected devices testing, I think as a tester, you'll be in demand for quite a while. So thank you very much for doing this, Randy. And to all of our listeners, we hope that you can join us for other webinars, which you can find at the @SQA website. And we look forward to providing more information and resources to you in the future. Again, thanks much.
Thank you, Dave.